Okay, so we can do it more than once. All right, so let's take a look at the limit as x approaches negative infinity of an x squared over an e to the negative x. Okay, all right, so first thing, I need to test my direct substitution. All right, so if I plug in a negative infinity, and I'm literally going to plug it in, okay, as negative infinity, quantity squared there in the numerator. All right, and I'm going to plug it in here as well. So I'm going to have an e raised to the negative, plug in a negative infinity. All right, now it's as x is getting bigger and bigger and bigger. Okay, but this is a really big number, negative, squared. So if I take a really big negative number times a really big negative number, I'm going to get a really big number. So the numerator is going to go to infinity. All right, if I take a look at this, a negative times a negative is positive. Okay, so basically I've got a constant being raised to a really big number, a constant as that number in that exponent gets bigger and bigger and bigger. It's just going to, the overall is denominator there is just going to keep getting bigger and bigger and bigger. Okay, so I've got infinity over infinity. All right, so definitely want to make sure you're thinking through this and you're understanding how I'm getting those indeterminate forms. Okay, so that's indeterminate form. Abbreviation there. What did I do? Sometimes my brain does not work. Why didn't I put that in quotes? Okay. All right, so L'Hopital's rule. All right. Indicate you're doing L'Hopital's rule. That way somebody that's looking at your work knows, hey, this person just did L'Hopital's rule. All right, now we still have the limit as x approaches negative infinity. All right, now again, let's try to do this without using that ddx notation. Derivative of that numerator is just going to be a 2x. Derivative of this denominator, e to the u, is e to the u prime. So the derivative of that exponent there is going to be a negative. All right, so I'll have a negative e to the negative x. Okay, so now after you take the derivative of the top and the derivative of the bottom, we're back to that direct substitution. All right, and again, I'm just going to go ahead and plug in that negative infinity. So 2 times a negative infinity. All right, a negative e to the negative, and then plug in negative infinity. All right, now actually I may do some more work here on this one. All right, so a positive number times a really, really big number, or as it's approaching a really big negative number. All right, so this top is actually going to go to negative infinity. All right, now this is negative times negative, which is positive, right? So this exponent is going to get really, really, really big, okay? And then times a negative 1, that makes this go to a negative infinity as well. Okay, so again, that's the variation of the infinity over infinity. It's just negatives. Okay, again, I've got an indeterminate form here. Okay, so it didn't work. One time of doing L'Hopital's rule didn't work. So now I'm going to do L'Hopital's rule again. Okay, so I need to keep my limit notation, the limit as x approaches negative infinity. All right, so derivative of that top, derivative of 2x is just going to be a 2. All right, now derivative down here, okay, e to the u prime, right? So derivative of this right here is going to be negative times the negative that's already in front. It's going to turn it back to a positive, and then e to the negative x. Okay, so I have now done L'Hopital's rule twice. All right, so again, let's try this direct substitution, see what we can come up with. All right, I can't plug anything into that numerator, so I'm just going to have a 2 up there. All right, now down here at the bottom, I'm going to have an e raised to the negative, plug in a negative infinity. Okay, so negative times negative, I'm just going to make that positive. So I got a constant being raised to a number that's getting bigger and bigger and bigger and bigger. So it's going to, if I wanted to show that extra step in there, e to the positive infinity. Okay, so this basically is just going to keep getting bigger, bigger, and bigger, and bigger in the bottom there, which is ultimately going to do what? It's going to go to 0. So then I'm down to an answer. Okay. All right, so good so far. So we see how we can do L'Hopital's rule twice. If I ended up with another indeterminate form here, we do it again. All right, you keep doing it until you can't do it anymore, okay? Or till it leads to an answer. All right.